Okay, everybody, I wanted to show you a little bit more about half and full wave rectifiers. We talked about this in class, but I wanted to make sure that we were going over it one more time. Now, not always, but oftentimes you'll find transformers involved in projects of power creation or power rectification. And when we have half a full wave rectifiers, we're talking about is we're coming off of a center tap of a transformer. And what that means is, first of all, a transformer is just two inductors, and the transformer itself could have a value. It could be 10 to 1, it could be 4 to 1, it could be 2 to 1, it could even go the other way. It could be 1 to 2 or 1 to 4. We're just transforming. It's how much of the winding on the secondary, how much of the inductive wave are we catching from the primary. So again, it's not magic, gravity doesn't go up, that type of thing. It's just physical creation of our primary and our secondary windings. We can physically pick up different amounts of power. Okay, so that's the construction of the transformer. But on the secondary, we also have different places we can physically tap into that inductor, into that winding. If I tap halfway up, I'll get half the value that I would measure if I went across the whole secondary of the transformer. So now I can physically touch my leads to the middle and I can get half the value, or I can go from the middle to the top and get half the value. In reality, these transformers come with all different places that you can tap, depending on what you buy or what's constructed. So you can hit different places on that secondary. For our half and our full wave rectifier, we want the middle because we're going to take equally half and we're going to fold it over and double our frequency. Okay? We're going to take an AC wave, we're going to fold half of it over with our diodes, and we're going to do that again and again. And so we're going to get twice the frequency, and we're going to get all our voltage peaks. Instead of having a peak-to-peak value anymore, now we're just going to have a peak value, and that's the value that we'll be concerned with. All right, so if I have different iterations, I'll just do this for my secondary now. This will be minus plus. This will be plus minus. All right, and so let's just go ahead and take a look at these diodes. If I have a more negative here than I do here, is this one going to open up? No, it's not. If I have minus plus, if I have more positive here, negative positive, this would be positive negative. So this one's going to be a go, and this one's going to be a no-go. Because of the direction of the current. So what I'm going to do is my current is going this way. I've got my plus here, my minus here. So my current is going this way. So I've got a dead leg here. I'm going to go out my ground, up through my resistive load. Here's my out. Oops. E out. And then I'm going to come back through this open diode, and I've got my completed circuit. Another way to think of this resistive load is, instead of out here, I could also show it. It might be a little easier to see. Instead of making this symbol, I just draw my resistor right here. Okay. So if I do it like that, we'll just not worry about that. That'll just be a really long test point. If my circuit is going this way, this part of the circuit is active. On my second iteration, if I'm going clockwise, now I have, let's see here. Oh, yep, negative, positive. So now that's a go. So I'm going around in circles on this half. So one half is one side, one half is the other side. Okay. So, but if I choose to put it over here, I can change how my circuit looks, but the behavior is the circuit is here, the circuit is here. And since I can't have both halves on, because my desire is to get a full wave out of this, okay, I can only tap halfway through the transformer. And I want exactly half because I don't want lopsided waves. I want equal waves. So that's why I'm at the middle. And a nice smooth output on my DC. Normally my wave would look like this, but now I'm going to take that rectified wave and I'm going to fold it up atop. I'm going to get rid of it on the bottom. Okay, so let's just say that this was 20 volts peak to peak. That's 10 volts peak. 2 waves at 10 volts peak. I want to take my DC average. Well, actually, first I want to subtract 0.7 for my diode in each side. So that's 9.3 volts peak is left. 9.3 times 0.637, and I get 5.924 volts DC. Okay, now if I add a capacitor in parallel with this resistor, I can forget about my DC average or my volts DC, and I can just leave it as 9.3 volts DC, because that capacitor, if it's performing properly, is helping smooth out this ripple so much that I hardly get any loss. So much of that average is recovered. Okay, so that's a full wave rectifier. Half wave is just saying I don't have access to both sides. I have an open switch here now on one of my 2 legs. So now I'm going to get a ripple, or excuse me, a wave out that is the same frequency as my wave in, but I'm just, instead of getting this wave and folding it over, I don't get it at all. It's just out of the picture. And I just get every other wave. And again, I can throw in capacitor if I want to, but instead of full wave 0.637, half wave, it's going to be half of that. So whatever, 637, so that's 3.318, 0.3185 if you want to be more precise. So that's that. And then sometimes you're being given values in RMS. Your RMS value is just it's 70.7% of your volts peak. So if I take 10 volts and I divide it by, say, 0.707, I get 14.14 volts peak. Or if in this worked problem we took 10 volts peak and we divided it by 0.707, we would then get, multiplied by, we get 7.07 volts RMS for this. So that RMS volts peak to peak is designed to sort of confuse you and force you to standardize things and get yourself into volts peak so that you can manipulate volts peak minus your diode voltage to get something that you can either multiply by your DC average or not. And that will then give us our E out. Hopefully this has made things a little bit clearer for you on the half and full wave rectifiers.